Hello everyone. So today we are solving the problem minimum adjacent swaps to alternate parity. So you are given an array nums of distinct integers. In one operation, you can swap two adjacent elements in the array. In an arrangement, the array is considered valid if the parity of adjacent elements alternate, meaning every pair of neighboring elements consists of one even and one odd element. Now you need to return the minimum number of adjacent swaps required to transform nums into a valid arrangement. If it's impossible to rearrange nums such that no two adjacent elements have same parity, return a -1. Now what is the problem saying? Let's say you have an array 2, 4, 6, 5, 7. What you can do is you can place the elements in this way, like let's say this is an example. You can place the first element 2 here, 5 over here, 4 over here, 7 and 6. Now you can check every two adjacent elements don't have the same parity. What is parity? Let's say 2 and 5. If you divide 2 modulo 2, then it is an even number, it is an odd number, then next again even, then again an odd, and then again an even. So this is how the parity goes, right? So it should be adjacent, no two different. No two adjacent elements should have same parity. Now let's take this example as well. So I will explain how the answer output is 3. First understand the problem. Let's say 2, 4, 5, 7. So what you can do is swap these two elements. You will get 2, 5, 4, 7. And in this arrangement the answer is 1. And this is the minimum you can do to make adjacent elements have different parity, right? Now in this you can see the array is already having parity, which are adjacent elements have different parity. 1 and 2 have different, 2 and 3 have different. And in this you can't arrange in such a way that every adjacent element have different parity, so you will return at -1. Now try to understand the first thing. See, I can directly say you how the code will work or anything, but you need to understand what is there. See, if you have odd, let me reduce the opacity. So let's say you had odd numbers and even numbers, right? Now if you have even number in your array as let's say 4 and odd number as 6, right? How will you place element that they will have different parity simultaneously, right? If you say I will start with the number are huge, so let's make it 4 and let's make it 2. I have just reduced the values by 2. So what will happen here is, if you had, let's say you will say 4 is 4, we have 4 odd, so let's start with an odd number. So let's say you place 1, then even number you have to place, so we'll place a 2, then again an odd 3, then again an even 4. Now you have to place 5 and 7 simultaneously, so it will be a wrong answer because 5 and 7 will have same parity and they are placed adjacently. So there is no way to place elements like these. So what is the first observation is, let's say abs of abstract value of count of even numbers and odd numbers should not be greater than 1, right? Should be less than equal to 1, right? Okay, the first condition holds, right? So what I'm saying is, if it is greater than 1, you will simply return false. You can't place it, right? Okay, the first condition is clear. Now what is the second thing you should notice is, let's say you have same number of even and odd. This is the only condition. Either you will have even and odd, let's say difference of them is either 1, or you can have difference of them as 0, right? No other possibilities will give you an answer, right? So think of this. If you had even and odd have same count of even and odd, means you had let's say same number of even elements in an array and same number of odd elements in an array. Now what will that do? If you have something like this, why is my pen not working? Wait a second. Now think of this. If you had an even same number 2 and 2, right? Let's say you have 2 odd even and 2 odd. Now in this case you can either start with an even number or you can start with an odd number and follow the procedure whatever is said, right? So this is the first case. When you have even and odd, both starting with an even and starting with an odd, both are valid and out of these you will find the minimum out of these, right? Minimum will give you a correct answer, right? Now let's say if you had not same number of even and odd, right? Let's say the difference between them all is 1, right? So let me first erase this. Okay, so let's say you had 2 even and 3 odds. Now think of this, if you had 3 odds, then you surely need to start with an odd number. So in that case you will start with an odd and follow the procedure of odd, then an even, then again an odd, then an even, and then again an odd. So this is the way, right? So I hope what is the logic behind starting with an even and odd is clear, right? So first things are, if you had let's say same number of elements, you can start with either odd or an even, and out of those your minimum will be the answer, right? Now, I'm not saying what is the count of the number, but I'm just saying that will be the minimum, right? And if I said if you start with an if you had different numbers, so you need to start with the one which is greater in size, right? Because that's the only way you can place 3 odds if you start with an odd. If you start with an even, how will you place odd, right? Let's say you start with an even, so odd. If you start with an even, let's say you placed an even over here, then you need to place an odd. So then again you need to place an even, then again an odd, and at the last you will only left with an odd, which will make the 2 odd element adjacent. So that's not valid, right? Okay, so I guess starting part is clear, that what should be the starting element, right? Now let's see a dry run of this. How will our logic and counting look like? Let's say, let me reduce opacity and take another place. So let's say this, right? So first of all, see the time constraints. Time constraints are num.length is 10 to the power 5. So you need to think of a logic which runs in O of n, or at worst n log n case, right? You can't let go these numbers. You can't write code in O of n square, right? That is wrong. That will give you a TLE. So you need O of n. Now how will we count the numbers? Is we will pre-compute the indices where there are odd and the indices where there are even, right? Let's say I had this. So what are the positions which are having odd? 0, 1, 2, 3 and 4, right? It's look bad, right? So third position does have an odd number and fourth position has an odd number, and even are at 0th index, first index and second index. So see, every time we had 2 conditions, either start with the even or an odd, but here even is greater than odd and the difference is less than equal to 1, right? So I can start with the even and this will be valid answer, right? So let's start with an even, right? So I'm showing it over here. Let's say you started with the even, right? So even is here, so you need no swaps, so 2 will remain here, right? Now 4. Now see, 4 is not at its correct position. This should be an odd place. So while we are counting, we will simply not think what will be our final array. We will simply think, okay, what should be the swaps to get the answer, right? So if you see 4, what is actually happening now, it will find the nearest odd and it will swap them and get over here. So ultimately it will become 2, 5, 6 and 4, right? Just to get a correct number. And in this you have swapped 2 times, right? Okay, I am showing what is actually inside the loop, what is happening actually, right? Let's say next one is I have this array. Let me remove all. Oh no. Let me reduce these, right? Okay. So what is the approach I am saying is, you will have this array, right? You will have 2, 5, 6, 4 and 7. What you have done, you have swapped this 4 here, over here, this place, right? Oh sorry, 4 and 6, right? So you swapped 5 with 6, 5 came over here. You swapped 4 with 6, 4 came over here and 6 was here. Now see, what is next? You took 2 ways, right? Now what is the next condition? Next condition is 4 and 6 both have same parity. Now you will swap this 6 with a 7. You will get 2, 5, 4, 7 and 6. which will take plus 1 moves. So ultimately 2 and 3 moves will be required if you do so, and that will be your minimum answer, right? Now this is the array which I am talking about, right? How will we count it, right? That's still not clear, right? So what we will do is simply count the required positions, right? Let's say we are starting with an even, so we have even indices already stored, right? And we have odd numbers already stored. In this case you can only start with the even, so we'll think only of even, right? So required is 0 to 4. What does this mean? You will place all even integers at even indices, right? Let's say this is the case. You are placing all even number at these positions, right? So you need to simply find the difference between the required is 0 to 4, and you have even at 0, 1 and 2. So difference of these will give you an answer. So 0 minus 0, abstract difference is 0, 2 minus 1 is 1, and 4 minus 2 is 2. So 3 swaps are required, and you don't need to first show the array, but I have already shown you what will be the behind the scenes of this, right? So 3 is the required answer of this test case. Now let's take this example as well. See, even are at 0 and 1 index, odd are at 2 and 3 index, right? So you can start with either even and an odd. So let's say if we start with an even, required will be 0 and 2. Even if you start with an odd, you will have to place the odd at 0th index, because you are starting from even indices, right? So you will be placed at 0 or a 2, and you need to place odd elements at that position, right? So even is already stored 0 and 1, right? So what is the difference? 0 plus and here 1, so it will give you a difference of 1. And if you start with an odd, it will give you 2 plus 1, 3. So 3 difference is there. So answer will be minimum of these two. Now if you want to see the behind the scenes of how this is working, let's say you had 2, 4, 5, 7, right? Now what is happening is, first let's say we started with the even, right? So 2 is here, no worries, we left it here. 4 will get swapped with 5. So in one move you can do this, right? And see, in only one move you are able to complete this array, right? Now let's say we want to start, no, you said no, I want to see what if we started with an odd. So 2, 4, 5, 7, right? So what will happen is, you will swap this 5 with 4, and again this 5 with 2. So 5 comes over here, 2 comes here, 4 and 7, and in this you took plus 2 moves, right? And clear? 5 with 4 is 1 move, and 5 with 2 is 1 move, right? So 2 move. So you have started with a 5. Now check 2. Okay, it's correct. 4, no, here should be a 7. So 7 will get swapped with this, and it will become 5, 2, 7 and 4. Yes, now that is what you wanted, and in this you took plus 1 move. So ultimately 3 moves were required, which was our answer also. So this was the whole code logic behind this. See, just understanding the code won't be helping you, but understanding the logic behind will work you a lot, right? So that's what I'm doing here. Let's see the code part. Now you are I'm describing even and odd, right? And simply traversing on the whole nums array. And if it's an odd, we are pushing an odd. I will simultaneously put all elements which are odd in the odd vector and even in the even vector, right? And what I'm doing is, see, I'm simply first checking if abstract of even dot size or odd dot size, if it's greater than 1, simply return a minus 1, right? That there is no way that you can place all the elements if the difference between them is greater than 1. And what I am doing is, see, if even is greater than equal to odd, what does this mean? Even vector is at least equal to or greater, then that means you can start with an even, right? And if odd is greater than equal to even, that means you can start with an odd as well. And these will give you an answer, right? You will give count and you will return the minimum of these, right? Now what's the count function doing? So it's simply traversing on the, it will get an array, let's say ARR. What is ARR? Let's say when you are solving for even vector, you pass the even vector, right? So here ARR represents even or odd vectors, right? So which function is calling that will depend on these, right? Now what we are doing is, we will simply traverse on the array vector, right? And our answer will be answer plus abs of ARR minus 2 times of I. Now why 2 times of I? See, if you are starting with either odd or even, doesn't matter. What are the index you will be facing? You will be facing 0, 2, 4, 6, 8, right? So that means array of 2i, right? 2i is nothing but representing these. See, if I is 0, so 0, if I is 1, so 2, I is 2, then 4. So these are the values with which you want to place your elements, and you already have the indices where already your even or odd, whichever element you want to place, is already stored in this, right? So you are simply subtracting those numbers and returning your answer, and in the end what you are doing is simply returning minimum of whatever the count 1 is there and count 2 is there, right? So let's quickly discuss the space complexity. You are creating two vectors, right, of even and odd. So it will take 2 into n, right? Big O of 2 into n. And what is the time complexity? It is, you are traversing on all the elements of nums, so big O of n over here, and you are checking, you are calling a solve function that will also at most take, not at most, it will have n by 2 elements for odd, and n by 2 odd, at a worst case it will have n by 2 for odd and n by 2 for even as well, right? So that ultimately gives us big O of n only, right? So time complexity is also big O of n, right? So that's it for the code. If you like the video, please do subscribe my channel, and if you have any other doubts, you can definitely ask in the comments.